I'm doing down positive.
And so 0 plus 9.8 times 3.7, and you get 36 point something?
Yeah, 36.26 meters per second.
Now the question I asked was how fast. That is asking for a speed, and so because we chose down positive, the velocity and the speed look very much alike. Officially, there's a subtle difference. Officially, for velocity, there's an understood plus sign right here to indicate direction. All right, questions on this before we make it more complicated? Let's keep the same cliff. So this is going to be 67.0081 meters. All right, so ball is thrown upward. There are occasions that I'll first write this as the ball is thrown up. Please recognize that that's a directional thing, not a euphemism. Thrown upward from an edge of a 67.08081 meter cliff near the surface of the earth with an initial velocity of 20 meters per second. How long does it take to hit the ground? Low, and up. All right. All right, so besides the height of the cliff, actually, no, I'm gonna leave that problem as is. I'm gonna erase this over here. So let's start out with, what do we know?
The initial velocity
Is
is 20 meters per second.
And displacement,
is
67.081 meters.
081, right?
yeah, 081.
Acceleration is still the same.
Is it what?
It's still the same. 9.8 meters per second squared.
Oh, yeah.
Hold on, why would our change in x be the same if we're throwing it up now? Wouldn't we have to account for the up part of it?
No.
No,
That's the beauty of this, is we don't.
okay.
Wait, so we always assume that the height is the same as the displacement?
In this problem it is. I hesitate to go with always,
Okay.
because there's another variation of this where it would not be, which we'll get to. All right. There is a problem with what we have written down. I want to solve it with what we have, just to show what would be a warning sign that something is wrong. Now, if you have a question about this, I'm fine. If you want to correct the mistake, hold off for a moment. You about to correct it or had a question?
Well, there's a problem with the first problem we haven't corrected that yet.
Oh. What was the problem with the first one?
We didn't find the height of the cliff.
Yeah,
Yeah,
that
the
was,
height of the cliff plus however tall the guy is.
oh.
How was the
I've done that before on test too, where I threw the height of the person into it. Yes,
Sorry. Again,
from an edge of a cliff, so the person is,
pushing the ball off the edge. There you go. Easier to revise the drawing.
all right, yes. All right, so which equation would we use in order to find time?
The third one. Or no, no,
Or-
The
Third one?
not the third one, sorry.
The last one.
The fourth one, yeah, don't forget this. All right, so if we use the last one, we get 67.081 equals 20t plus 1/2 9.8t squared. And so we're dealing with a quadratic here. So let's set it equal to 0. I'm going to bring this over to the right side, so I have 0 is equal to 4.9t squared plus 20t minus 67.01. Take a quick moment here just to make sure that it's going to do what I want it to do. Yeah, I did it right. All right. Now, quadratic formula, if you need to know, you can just ask. And I put it on the board if I don't already have it on the top of the test or quiz. I think at this point it's on the top of the test or quiz, but if I don't have it and you need it, just ask for the quadratic formula. Stupid earworm is in my head now for the, should never watch that video. All right. So negative 20 plus or minus the square root of 20 squared minus 4 times a times c divided by 2 times a. We'll have two answers. Mathematically, we'll have two answers. Both answers won't necessarily make any sense.
Yes.
So if we could have, first, the discriminant. Discriminant's the part under the radical, so if someone could tell me that first as we work our way through here. Plus or minus the square root of something over 9.8.
Uh, 41.4, you want 1 or do you want 0.9999396?
Do I want what? Oh, for the final answer?
Yeah.
No, I want what's under the radical first.
Right, that's what I'm saying.
Oh,
He's like asking you want it rounded.
Yeah. Do you want 41.41 or do you want 41.409999396?
1 decimal place is fine.
Okay, 41.41.
Anyone else get that?
Oh, I already,
That's
I square rooted.
that's already square
Yeah,
root.
my bad. So what you're looking for is 1714.7876.
I,
Is this what I got, but I meant you?
oh. This is not the problem. Hold on just a second. I messed up then.
Yeah. I'm not even gonna try this.
Oh, no. Different from what I was going for. All right. So what are my final answers?
Uh, 2.185. and negative 6.266.
This is not gonna have the big red flag that I was hoping for, cause I know brain glitch there. There is a problem with this. Oh, well, you know, we'll just keep plugging through. We'll find a mistake. All right, so we have two different times there. So which obviously is the answer that makes sense.
So 2.185.
All right, so let's figure out how fast that thing is going. What's the velocity? Let's try that third equation. My final velocity, or my velocity at that time, is gonna be my initial plus 9.8 times 2.185.
Didn't it take like 3.7 seconds without the first one?
Say it again?
Didn't it take like 3.7 seconds without throwing it out?
Yes, yes it did. There's one warning sign right there.
Okay.
And the other warning sign is, what's the answer here?
41.
Or 4.3.
meters per second.
Wait, and yeah, that's bigger than our initial velocity.
Yeah.
That doesn't make any sense.
So when you get on a test and you get an answer like that, ideally you look at that and go, wait, that doesn't make any sense. It can't be going faster than it was initially thrown when you throw it upwards. So then you'll go back and try to figure out where the mistake is. So where is the mistake?
The sign on the acceleration?
All right, so let's make that acceleration is negative. Is that what you're saying?
Yes.
All right, so let's work that through. So this becomes negative right there. This becomes negative right there. And this becomes negative right there.
But down is positive. So how is acceleration negative?
Our starting
He
velocity
just
is-
established a different convention there.
Our starting velocity is
Yeah,
positive.
starting velocity is positive, that makes sense.
Oh, guys, okay, never mind.
All right, so what do we get? What's the discriminant now? The part just under the radical. Don't take the square root.
Alright. Negative 914.7876.
So what happens now?
You can't square root the negative number, can you?
Like again, but
Yeah, it's an imaginary number.
yeah. So what does that tell us?
There's still a sign on.
Yeah, it's either wrong or the problem's impossible. So the question is, think through physically what's happening here. Person standing over a cliff, lying on the ground, I'm not gonna do it, but lying on the ground, throws it up, and then it hits the ground. Is that problem possible for someone to throw an object up in the air and have it hit the ground?
Yes.
Yeah.
Okay, so we've made a mistake. What is the other mistake?
The sign on the displacement? The sign on the displacement.
Yes.
Oh, because up is positive.
Whatever convention you're doing, these two will be the same sign, and this one will be a different sign.
So now we do it again.
So now, this becomes, when it comes over, that will become a positive, because that will be a negative there, which makes this positive, which puts us back here again.
I'm on it.
525915.04.
Say it again.
525915.04.
Oh, the discriminant.
Yeah.
Why is it different from this?
Hang on.
Unless
I don't
wrong.
think that's,
I got a 1714.
yeah.
Okay, let me see what I have.
I got the square root of 1714.7876. It's basically the same thing as the other one. I think, I don't know, I'm curious as to why this isn't possible that we have a final velocity that's faster than our initial, because even though we threw it up, you know, it's gonna take more time to reach the ground,
All right,
which means.
no, all right, so initially it was greater than, because the problem we actually solved was, we throw the ball in some direction,
Right,
the acceleration was in the same direction, so
Right.
it's speeding up,
mhm,
and we're trying to figure out how much time does it take to get to here. So that,
so we did the problem wrong, because we're starting,
So we're trying to find the maximum height or the thing over the whole?
well, we're starting at a displacement that doesn't take into account that we go up and down.
right, the initial problem without the minus signs there is, we throw it in the direction it ends up being, and it's accelerating in that direction.
Right,
So it's getting faster and faster as it goes. When we just change this one right here, this negative sign here, we now have it still going upwards. 20 meters per second upwards, it's slowing down. How long does it take to get to here? Well, that problem was it doesn't get there. It stops before it gets to the 67.081. Now it is a possible problem because we're throwing it up. It's gonna slow down at first, and then it's gonna speed up going down and end up 67 meters below where we started. That's the problem we're working on now.
wouldn't that be position though? Displacement is, the total distance, so, cause we have to add into a, no?
Displacement is where an object is relative to its starting point.
Okay,
We didn't add in the distance up. did we?
It's built in.
The extra time is factored in with the change in sign on the velocity, so wouldn't the answer just be positive 6.266?
Yeah, there's a minus sign off here, so, oh, that's right, because that 4.9 that's now negative, positive. There we go. It is positive 6.266. Yeah, I guess officially that should have been a negative when we were doing that one. Tell you what, I'm gonna rewrite this, with these issues right here, or with those values right there with it properly, so that we have at least a clean version of this on the board, as opposed to 3 different problems written on the same stuff. Alright, that's valid. I'm gonna leave that. I'm gonna get everything over to the left side, just because I like my starting term to be positive, that's just a me thing. So I have 4.9 t squared minus 20t minus 67.08. Fourth time I've done that, 081 meters equals 0. So t is equal to 20 plus or minus the square root of 20 squared, it's negative 20, no, 20 squared. No, negative 20 squared. It doesn't matter. It's 4 times 4.9 times negative 67.081 divided by 2 times 4.9. And so we end up with 6 point, in the old board, I used to be able to still read it. And then negative 2 point something. What was this again? This is,
I think it was 266.
man, my brain is off today. All right, and
185.
now there are 2 reasons why I knew something was off in that answer there when I just circled it. One, from the point that Isaac made, if I just dropped it, it was 3.7 seconds. Now I'm throwing it up in the air. If nothing else, from the peak to the ground, it starts at 0 and goes down. It's going farther than it did before, so it better be something bigger than 3.7. The other issue is, if I actually did displacement versus time graph, it starts out getting a positive displacement, and then it comes down to here. That's basically would be the displacement versus time graph. And so this would be negative 67.081. Didn't write that time. Meters. What the math is looking at is that all the math sees is a parabola. I have a parabola here. Sort of extend that backwards. It has no idea about physically what's going on. That's for us to interpret. And so what we're doing is we're solving for the time here and the time here. Because it's initially thrown upwards, I know that the negative side of it, if I went backwards in time, that is a much shorter distance than that is. My positive answer better be bigger than the magnitude of my negative answer. So that was the other thing which was telling me something was off.
Well, you said we couldn't have a final velocity that's greater than our initial velocity?
All right. That would be a larger, because before we threw it up at 20 meters per second, and by this,
It's 0 when it reaches the top,
yeah,
and then it comes back down.
right. So before, we had the final velocity in the same direction as the initial velocity, so it was upwards.
Okay. So now
Going
we have
faster
to-
than when you first threw it.
Now you have to subtract the initial velocity from the final velocity?
Now, no, we did the exact same thing we did before, except now our acceleration is negative. So we end up with 20 plus negative 9.8 times 6.266. Probably, it could quite well be going, probably, well, actually, it will be faster than when we just dropped it, but at least now we'll have a negative velocity.
Right, it's the same as before, but just negative.
Okay. No. Oh. Could be, we had a different time last time also.
But so, I still don't get why, so why would the displacement be like negative? I don't, cause it says you throw it from a cliff that's 67.081 meters high, so like, wouldn't that be positive? Like, I don't know
Where,
why you start.
where does the ball end up? At the end of the problem, where is the ball?
It ends up below the ground,
Below the starting point.
below the starting point.
And because up became positive, below the starting point would be a negative value.
So then, but how would that make the displacement negative though?
Displacement is where an object is relative to its starting point. So just like when I was moving back and forth, my displacement was negative when I was on the negative side of